We're looking at how sucrose depresses the vapor pressure of water, and we want to find out what is the maximum amount it can depress the vapor pressure. We know that for a saturated solution you can have 230.9 grams of sucrose per 100 grams water if you're at 20 degrees Celsius. Remember that the solubility is a function of the temperature. And we also know that for a pure water, the vapor pressure at 20 degrees Celsius is 17.5 torrs. So if we look in the overlay there, what we're trying to do is go down the end. I'm not sure if you can see this, but we're at the end here where the mole solute is, and we want to go this way until we reach a saturated solution and see how far down we go, okay? So, the first thing we need to do is look at the equation for describing vapor point depression, a colligative property. And we know that the change in the vapor pressure of the solvent, which is H2O, it's a depression, so it's negative, and it's proportional to the mole fraction of the solute, the sucrose, C12H22O11. I'm just going to write SUC for sucrose, times the vapor pressure of the pure solvent, which is H2O. Now, what do we have? We have the solubility. Okay, we know that the solubility of sucrose is the number of grams, 230.9 grams of sucrose will dissolve in 100 grams of water. Okay? Now, what we need to do is extract from this the mole fraction of sucrose. So we need to calculate for 100 grams of water, we have 230.9 grams of sucrose. We need to recognize the number of moles of each of these. And note, by the way, this has more mass, sucrose, than water, but because sucrose is such a large molecule, the number of moles is much smaller, okay? So let's first get the moles of sucrose. So I'm going to write N sucrose. And that is how many moles are in 230.9 grams. And it has a formula weight of 342.29 grams per mole. I'll write the mole up here. Now I'm going to run out of room if I'm not careful. And it's 0.67456. 0.67456. Is that on the board? Yes, it is. Okay, now we need to calculate the number of moles in 100 grams of water, NH2O, which is equal to, well, we have 100 grams. And this, by the way, is an exact number, okay? It's the number of moles per 100 grams. And we have around 18.02 grams per mole of H2O. And this will be equal to 0.55556, okay? So there's the moles, and this is moles of sucrose, and this is moles of H2O. Okay, now the mole fraction X, okay, I'll write that here. The mole fraction X of the sucrose, the solute, is equal to the mole sucrose, this is 5.5556. It is 0.67456 moles of sucrose over 0.67456 moles of sucrose plus 5.556 moles of H2O. And the mole fraction of that is 0.1083. 0.1083. Okay, so what this is saying is that we can't have a large mole fraction of sucrose in the solution because at 0.1083 it becomes saturated. So the maximum delta P we can have is a minus 0.1083 times the pure, which was 17.5 torr. And so this is equal to 1.89 torr. So if we look at the vapor, at the Raoults law, that small part right there is the maximum depression, and this whole part of the line from there to there, from like around here to here, cannot exist, okay? You can only go in the range of the mole fraction sucrose from 0, the pure water, to a value of 0.1083. At that point, you have a saturated solution. And so this is the maximum the amount of the vapor pressure can be depressed by adding sucrose to water.